Thanks everyone for joining in to the last session this week, where we basically have a lecture slam of three different speakers, like distinguished speakers who have somehow engaged in innovating and developing making and digital fabrication. And as we outlined before, like the idea of the Digital Fabric Maker series is basically to bring out the idea of digital fabrication into the world of producing architecture. So we have actually a lot of knowledge in the academic research. We teach digital fabrication, but the architects are not using it widely. So our idea is to set up this series of lectures to hear from people who are actually implementing digital fabrication in their work. And what's interesting about it, of course, or what's interesting us especially, is that you lose that borderline between the demarcation between designing and producing. So there's a new way of making architecture. We can reach out into kind of fabricating architecture ourselves, or we can be part of it. And so we think that there will be a new way of looking at architecture, because since the Renaissance, this has been always the kind of borderline, and we would like to see how that could be loosened up. So we're very super excited today to have Arthur here from London. This is basically crowning the lecture series this week. And yeah, Arthur is leading a company called Mamou-Mani Limited, I believe. And basically your office has been going for about 10 years now, since 2011. And you work in hugely imaginative, fantastic architectural proposals, visual merchandising services, workshops, software classes. You do kind of everything at once. So it's really hard to follow up exactly what to mention here. But I think it's what I'd like to mention is you're also a director of the FabPub, which is I mean, you basically produce, or people can come to you to produce their work, digital fabricate basically their work. And I know you just told us you moved into that huge new hangar, which which is full of that equipment, and it sounds like a lot of new things will come out of it. We hear also that you are working on a lot of new projects which you can't show tonight, but you're also working in Germany and Frankfurt, and so we're very curious to see that in the future. But Arthur is also a lecturer at the University of Westminster. You teach also in Spain, I saw recently. You started last year, I
The
think.
Yak, yes, that's
Yes.
true. Yeah, very nice school. Yeah, yeah.
And in Catalonia, and the
Mm,
senior faculty of MACAD.
mm.
And yeah, and you were originally from
From
France,
France.
and
Yeah.
you studied at the École d'Architecture de Paris Malacquai. I don't know.
Marie.
But okay, thank you.
Yeah,
And then afterwards at the Architecture Association in
yeah.
London. And the list goes on. So
It's
I could add more, but I think we would love to see you work now, and so the floor
yeah.
is yours out there.
Thank you so much. So I'll try and share my screen, and if you can just confirm that you can see something, and I'll try and
Yes,
keep your
see
your faces on another side. So
ya.
it's nice to see your reactions. But thank you so much, Martin. It's a real pleasure, really, especially because I love Stuttgart and what the I guess what the city represents in terms of architecture, and it's such an honor to know that some of you are related to Frei Otto, who's of course with Gaudi, the biggest master of parametric architecture. And so it's I came several times with my students because every time we come, it's all about innovation. And you said it really well about the blurring lines between making and designing, because that's really what we are experiencing here. And I'll try to explain that and how somehow we ended up, in the desert building this gigantic temple, but and on the way started using, eco materials, and people really approached us for a more holistic view on design that doesn't just include design and making, but also making and designing responsibly and with circular economy in mind. So that's why I mentioned eco parametric. So just added the word. You had Jonas Lundberg as one of your lecturer, who's one of my teacher. And when I was studying with him, we looked at how to link the environmental parameters to our models. So it's definitely in a continuation of what's been shown. So this is our office just before we move to the hangar where we are now, which is not far from that office. But I like that picture because it's very representative of what's going on. Basically, we're surrounded by large scale models, and the reason being is that downstairs we have. You mentioned the WASP printers. We have quite a few of those, the 3 meters one, which allows us to do one-to-one, very, very large scale models, which is something that wasn't even thinkable when I was at the AA 10 years ago, where we were just, these tiny printers, these tiny lasers. But we knew something was exciting about it, but no one realized that they would become huge machines that could actually do architectural components. And I think that's what, and I just remember working in a practice and thinking, it's a shame, like I cannot use my skills that I learned. And there's no
Yeah.
company that allows me to 3D print huge things, because we're talking, I don't know, 2008 or something. And it's just so. And often when I go to Stuttgart and I saw these giant robots, and people that graduate from there probably are like, oh, where am I going to work? Because where do they use giant robots? Like all the established firms don't have a robot in their office, right? And actually, it's surprisingly happening. But I guess in this case, the company stemmed from the fact that we couldn't find, I couldn't find a company that really pushed that to the level that we could push it at the same time. So basically, at first, I didn't create an architectural studio, but a fabrication space that I thought would be part of this whole democratization of 3D printing, laser cutting, and so on. And hence the name FabPub, Fabrication Public. And like you say, it's accessible for people, and it was great, but people didn't know how to use the machines. So then the clients would be excited, but didn't know how to use them. So then I sort of freelanced as Mamou-Mani to help people, and then it became an architecture studio, and we ended up being hired as architects, which is why there's this duality between an architecture studio and a fabrication space. Both companies are now doing well, but it's funny how the architecture studio was maybe more recognizable in terms of like an income stream or something. And so therefore we ended up helping a lot FabPub until FabPub had a life of its own and is now doing maybe better than us. So it's an interesting duality between what's very personal and very identifiable as an architecture studio with a signature, and then what's very public and for others to use. And there is always this dance between the sort of architecture and the fabrication and the public and the I wouldn't say the private, but the personal, the public and the personal. And so this is downstairs now. Now that machine is inside our space, but one thing that we were trying to do is understand those machines and not just send things that have nothing to do with what those machines want to some extent. So, we were working on several things, including our custom G-code software like Silkworm, but also large scale machines that could break the barrier between small scale 3D printing and huge cranes, like when you're on site, obviously everything is messy and it's unlikely that we'll just be extruding gigantic building. I mean, maybe we will, but a lot of prefabrication is very important. So we won a grant from Arab to develop a cable robot, which is really the mixture, the merger between what could be like a 3D printer and a spider cam or a crane. And the excitement came that we could possibly build skyscrapers with that and then unbuild them when you don't need them anymore. And I always
Mm.
witnessed like that we tend to see architecture as permanent, and that, maybe it's because I go to Burning Man and stuff, but really when you go to nature, when things don't work out, they die.
Right.
When you're in cities, you build a huge structure and then it just remains empty if the economy collapses. And so in the spirit of what we learned at Burning Man, and I'll explain a little bit about that place, the idea of leaving no trace or being able to do an architecture that can leave no trace is extremely important. In the context of Burning Man, but in the context of the circular economy, I don't know if you know about the three, reuse, repurpose, recycle, reduce the use. So all of these are very much in line with the idea of designing something that can be also undesigned or disassembled or removed somehow, so that you can leave a space the way it was. And so those are really interesting aspects of Burning Man that we brought back. And I'll show you how it sort of scaled up to the temple at some point. But of course we do crazy things, but we also do relatively conventional, if you can call this a conventional staircase, but this was all produced in our space with laser cutting steel, laser cutting ply. And so we act as contractor for relatively normal projects as well, like these houses. They always become crazy because obviously the actual general contractor is like, well, what is your role, since you're just going to produce that staircase? Where do we fit you? And so it becomes interesting contractual conversations. Um, but often it's a little bit more abstract. Like here we worked with Studio Precht, Chris Precht, an amazing architect from Austria. I think he lives in the mountain and is very keen to do environmentally friendly things. And he asked me to work with him on this project in Saudi, in Riyadh. And we both wondered, like, should we do it? Because obviously it's the land of petrol. And we were not so keen about that. But then we thought, well, maybe we challenge them and ask if we can use local material, in this case, sand, and see if we can actually use technology with local material. And so somehow we convinced them to use this sand printer. I'm sure you know that they're used for molding metal. And so the companies there were just not used to using them for 3D printing a piece. And we had to build and destroy so many of them before we actually get to a sense where the thickness, the minimum thickness, was strong enough to handle people climbing it and so on. So this was a very interesting aspect of, well, actually, all these projects is that we break a lot of things, and I'll show you a lot of the things that we end up breaking. And the reason being is when you have a new material, a new technology, and so on, you just, it's not certified, it's not here. It's not proven stuff, and so you kind of go in a zone where you're on the edge of failure all the time, and you spend that time on the edge, and it's not just exhausting, it's a challenge, and you have to have clients that are on board with that. And so the temple is obviously one of those larger proof of concept, let's just say, of that approach, where we ended up being the contractors, the designers. We also fundraised for it, fundraised about $600,000. We had to convince that it was stable. We had to use off the shelf material. Everything in that project was a bit of a challenge and a real collaboration in some sense. And so I'll take you there. I'm keeping an eye on my clock, so everything will be okay. Uh, but I think what I've really been learning, I mean, I graduated roughly when Grasshopper was created in 2008. And I just remember the enthusiasm of being able to share knowledge. And I think as architect, we're not quite used to that, especially before. I mean, you'd read Detail magazine, you'd copy some details, but I mean, that's about it. But when we started writing software all together, as a community, and we shared that software, then we ended up sharing literal tools with each other, and that just became like whoever we need a plugin to do physics simulation. Okay, boom, Kangaroo. We need a plugin to do Catmull clock on Rhino. Boom, Weaverbird. And everyone started sharing things and noticed a hole in the ecosystem and just jumped in to provide help on that hole. And how amazing is that everyone came together to do that, mostly for free, just that the love of sharing and gift. And And I thought this was a very inspiring thing. But again, like I think, how do you apply it in practice? How do you apply Kangaroo or robotic software in practice? And there wasn't much at the time of like outlet for these apart from maybe formal exploration and on large. So quickly, you mentioned visual merchandising. Like the Royal Institute of British Architects noticed that I was interested in craft, and they paired me up with a retailer called Karen Millen, like a fashion house, and 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 then said, well, I think that could work out. Like here's a shop window of a 30 meters, like do something there. And I started showing them the tools, really just genuinely thinking it's interesting to use your material and apply some parametric intelligence to it. And I showed them this simulation, I remember at the time, and they were just like, that is incredible. That means we can use our materials, link them with some kind of like three-dimensional simulation and create variation on our materials. And it's not only did it create a shop window installation, but they used it for their own collection. They ended up like giving us 5 projects. So we ended up somehow becoming like this visual merchandising where we did so many pop-up stores. And I think it's because the scale of the printers, the scale of the lasers we had could only lean towards either pavilion or shop windows or pop-up stores. And it was a big period of pop-up stores because at the time everyone started shopping online, so the main street didn't have any outlet for like they were doing bad, and so experiential marketing, all these things started to emerge. So we ended up doing a lot of that, and it wasn't part of the business plan, but it just
Mhm.
happened. It's interesting to see where you end up with that technology. And so these are matrices. Like we would explain to people that it's a parametric design, so it's not just one form; it's a system of forms. And this became really really important in the way that we communicated projects and that we showed that what we design is not a design. It's many. It's almost like a sort of a DNA of designs that could self-develop. And I think that's really important because the word design is loaded. Is loaded by the ego. It's loaded by the idea that the architect is drawing something and then it's sort of all in his mind and or her mind. But it's not at all like this, and it's never been in our practice. And I say this genuinely because, for example, this was Bura Happold, the engineering company that saw the shop window next to them because it's on Oxford Street, and they said, "Well, can
Yeah.
we have it in wood?" Because it's our anniversary and we want to have like a special zone and we want to feature wood and technology. And of course, like I had no idea if you could do it in wood, but we noticed this open source technique called lattice hinge, and then ended up doing the same process we did with the Karen Millen stuff, but with plywood. And so we reparameterized. I mean, you probably all know all this. The surfaces. We mapped this lattice hinge, compressed the NURBS domain, and then created like curvature based on where that the compression of the Bezier spline is, and et cetera, which allowed us to do these flowing geometries, and all these possibilities were then implemented into these ceiling panels that had all kinds of technology behind it. But obviously, there's no contractors that can just install that. So we ended up being the contractors, and so we installed this. We did all the machinery, the linkage, as much as we could, the building regulations aspect, the certification, the acoustic panel, et cetera, et cetera. And this gave us a lot of freedom because if we failed, and we did, we failed many times on that project, we could redo the entire thing with minimizing the expenses because the raw materials are really cheap. And the laser, we managed to like fundraise to get a laser for our company. So we ended up being able to experiment and iterate so many times. And there was no choice but to do that. The boss of Birapo was like, can you round the edges? And like, after we build the entire things. Like, okay, fine, fine. And so you look a lot less at your losses, and it's really important when you innovate because there's just no choice. Like it's new. Everything is new. There's no product you can buy. And so this ends up developing product, not just projects, because we ended up using those wooden waves a little bit everywhere. And we installed it just
Mm.
now at the Orange headquarters in France. For example, obviously I can't show you just yet, but I'm happy to show you the variations, like so many variations of the project, and every iteration we learn more. And so that's a fantastic thing when you end up developing a product as an architect. You can actually become an expert at something, and it's a weird thing. It's a wave, from plywood, but it becomes something. Um, a lot of, I mean, a lot of what we do is obviously growing from parameters. I mentioned like the idea of letting the simulation do things to, and so this was a very, very early project, but it ended up becoming Galaxia. So that's why I'm showing that every project has the seed for our next project. So you probably can predict a lot of what we're going to do. This is using Hoop Snake on Grasshopper. There's Anemone, for example, where you grow things. So you tell a vector to go somewhere, and then you recurse. So you do recursion, and then it sort of grows. And then as it grows, you can actually add parameters like the sunlight entering the space and so on. And that project was a very early on proof of concept for a hotel for astronauts for Virgin Galactic. And I show it because a lot of this explain a lot of what happened. You see the system wasn't always a roof, sometimes was landscape. And so that idea of using a system for not just one thing came back so many times. And you mentioned that there's too many things we do, so it's hard to explain what we do. And it's a lot like this, like a sort of open-mindedness to many things, not putting barriers, which might make it a bit hard to describe what it is we do, but hopefully there is coherence. So we ended up doing a software for 3D printing. I mean, it's a plugin really, and it's just extruding G code from polylines to give us that freedom to print things up in the air. And now there's plenty. There's like robot softwares and things that. But the idea originally is instead of like creating a shell and meshing and slicing it, is to export the movement and control the G code as you print. And so this kind of opened up a whole world of possibilities for us because we knew that we could then be freed from having objects that are solid, from having forms that we design, and to let the form be guided by the parameters of the material we were going to use. And quickly, we actually realized that the material we used was extremely environmentally friendly. And I think that's just a coincidence because I'm sure you use 3D printing and you realize that you're using PLA. And a PLA is polylactic acid. It's what you produce when you run, like lactic acid when you have a stitch. And this is a life cycle assessment. I put it because we talk about it, but we rarely see one. And we realized that if you use ABS, the conventional plastic versus PLA, you have a lot of things that are way better when you use PLA. One being, of course, like the toxicity of the material, the provenance, the depletion of petroleum, and so on and so forth. And when we realized that, we're like, oh damn, like we should talk about it because we use PLA because it's low melting point and therefore it's good for 3D printers. But what if we actually explored that as an actual plastic to replace the plastic that we use? And this was this Conifera project that we developed with COS. This was the managing director of COS who actually was kind of open to the idea of exploring new kinds of materials. And so this project was really an attempt to see the potential of this material as a building material. A little bit crazy because well, one, it's a huge project. It's about I don't know, 30 meters long. It's made of 500 of these bio bricks that were huge as well, and we had to print it in 2 months. And that's where I think the intelligence of like distributed manufacturing happened. So our lab couldn't build all these things, and so we called all the labs around Milan that had such a large printer, and we ended up distributing the files together. And that's a really powerful thing, I find, that when you start using code and that people have the machines that work with your machine, you can then distribute locally the manufacturing of things. And so that really opened up a whole perspective for us and why we ended up wanting to open more spaces across the world so that we can actually share the codes that. So it's a real new world where we will share files, not just the software. And it obviously comes with a lot of challenges, but from Conifera to the SendWave, we've noticed the power of sending these files around. This was the SendWave. I mean, it started with a giant Conifera cones, but we quickly realized we didn't have the right machines for it. Now, that's why design in that world of digital fabrication or digital makers is a little bit special because you cannot design something and expect a contractor to do it. You have to first find the contractors that can do it and then design. And that's really weird because it doesn't follow the stages of work. Usually you have feasibility, concept design, and then you find a contractor, you do a tender. But when you know you're going to use digital fabrication, if you do that process that is so linear, you'll end up with something that doesn't work. You'll have to redesign everything. So you go back to square one. So you might as well find a place that can make and then work with that place that can make with you. So here we found this giant like sand printers. We knew the dimensions. We knew we could print like a cube extruded. So we ended up printing these as a sort of yin yang fashion. And so we had two components to create two kinds of curvature. And then we ended up printing like a lot of them. But it was really, in that sense, hand in hand with the manufacturers because if you can imagine this is in sand. Sand doesn't take tension. And so we had to calibrate our Caramba model. We used Caramba with our engineer format to actually get the right thicknesses for the right spot. And so that was a really, really interesting process. All right, time to take you to, I guess I have about 5 minutes maybe. Time to take you to the desert. I'm still okay, right?
Yeah, you're still okay. We can also talk about your maybe we can have a quick
Yeah, happy
talk
to.
about this. I mean, because
Yeah,
this, I mean, of
happy
course,
to
there's
pose on
so
that.
much.
Yeah, of course.
Yeah,
Happy to pose and
yeah,
then go back to it. Yeah,
exactly. I mean,
great.
let's try. I mean, basically, there's so much of your work here. I mean, there's so many
Of
questions
course.
already. So, I'm thinking, gosh, how to get all the answers. But I mean, you mentioned a lot of things that are super interesting. And what, I mean, you basically, it means that unraveling the whole process of, architectural design, like the whole
Mm.
like making, and you said like you have this kind of swarm of printers, that in Milan that could just print your
Yeah,
work, and
yeah.
so you could team up with others, and we have also. I mean, yesterday we had a lecture by Jim Mendenhall, who is from Zena, and they also they work on these geometries, and they work basically in the US, and they actually team up with many people. They're a very multidisciplinary team where they have also
Mm.
artists working. And so it seems like that is kind of part of your culture, like this kind of teaming up with many others somehow. I don't know, like it seems
Yeah,
much more open in process than normally you would have an architectural office designing it all in-house and then finding a contractor and then uh, trying to make it realize. But I think what's interesting about this is when you're a startup, like as an architecture company, that I think you have what you said, you can have you the tools to produce this stuff yourself. So you can actually you could come to FabPub and with your file and print your first work, right? So it's you don't have to have a huge amount of money to go to a contractor and to kind of, you know, develop it. So did they have like was there something that was important? I mean, is this something that was driving your office in a sense, or is it like as a kind of when it started like 10 years ago? Like,
yeah. I mean, really, it's because we were taught to use these machines at school, and when we sort of, when I started to explore what to do with these machines. Well, one, you need to be able to have access to large scale ones. And there was this farm, it's still happening, a farm in Oxford that allowed you to use their laser. And for some
ah,
reason, they opened it up to other people.
wow.
And so I went there, I drove there and I stayed there. And it was basically just me and the laser. Like it sounds like a James Bond thing, but and literally just experimenting what the laser could do. And I just did this because I'm sure you're used to it, but at school it was new, but we would book a session with the laser and the laser cutting. We'd book online. It's very common at school. But in the
Hmm,
professional world, like where do I book my laser? And why would I book my laser? And not to
hmm,
do just a model, but to do the thing.
hmm,
And I think that was just like, why would I just model a representation of the thing, not why not the thing itself? And
hmm,
so, but what sort of project allows you to, or what sort of client allows you to like experiment with a laser cutter? If not, I mean, we're not going to build a house or a skyscraper with it, but for example, pop-up, are actually inhabited pavilion, right? They're a brand that want to have a shop inside, and so therefore they want something that represents their brand. And so that was perfect. That was like actually commercial pavilions, not the
hmm,
sort of university pavilion, not the competition where like all the architects apply and then it's all about the best render, but actual like working with a client towards selling something and providing an experience that's a bit magical using like a smaller scale. So and so there wasn't that many opportunities to do that in the now it's kind of a bit crazy because now it's very different. Now we have people like Orange Telecommunication that asking us to do their headquarters full of digitally fabricated stuff. And so it's a new world where we're actually general contractors. But it's really, I don't think I could have started with this. I mean, obviously now we hire
Mm.
people to work on it, so we have junior people that actually have a place to apply what they learn at school. So it's
Mhm.
like a new
Mhm.
ecosystem where people can do it. But there's no way I could have just started with this. So this process of starting small really helped understand like how to actually deal with these machines as contractors and deal with the degree of unknowns. Can we use PLA for a facade? And my clients ask that, and I'm like, well, we can get a certification from this and that, and like now I can actually help take that risk because I think it started a little bit smaller. Yeah.
Yeah, so you're basically prototyping, and by doing this yourself, you can always you know more about the risk you take, right? This
Yes.
is this is how I understand. Because I mean,
Yeah.
we have this. I mean, here it's also like everywhere. It's the liability issue. You're
Yes.
designing, and then your insurance insures only what you design. As soon as you start to build for yourself, your insurance says we're out of it. So basically, you have to make sure that everything is perfect. But the interesting part is what you're saying is you're testing, you're refining, you're making it better and better, and you can control that
Mm.
quality and you can optimize it in a way. Yeah,
Yeah.
like I mean, I know I mean, Achim Menges and Jan Tippers, they're working on a project. They won a competition for a facade where they do actually this kind of wrapping of fibers, and it's
Yes.
it's
Yes.
completely. I mean, it's completely unknown. So the client takes the risk, but I think it's something that is really hard to do
Yeah.
in the contractual world. So I think what's interesting about your work is you actually can, because you do it all yourself, you do it entirely yourself, you can actually you have much more control of it, and you can make sure it works in the end, I guess.
Yeah, and you take the risk fully. So it's I mean, risk is also reward. So if it works, it's you have a product that people want, and we've been lucky that it's gone the right way. But that's obviously like higher commitment because it's way easier to specify a product that exists. It's like there's almost no risk, right? Like you
Right,
just and if there is a risk, then it's on the person that sells that product. And architects became specifiers, like
right.
we end up like saying we want that kind of tiles, that kind of, and then we make mood boards and stuff like that. And then we end up like as purchasers. So we become the special gate towards purchases. But when you're a fabricator or when you end up like having your machines and stuff, like you're like, oh damn, okay, so that's on me. Like I have to
Mm,
actually give a certificate of this or that, and then I have to actually be behind it, and I have to explain to the client how to connect it, and I have to do a manual of how to use it, and suddenly your scope of work become huge, and what you have to do to prove it is, and so then you build all that knowledge and IP, and then you're like, well, for the next project, I might as well sell or continue like it's like for the wooden wave, like we just keep on going back to it because we already have so much knowledge on it. So I can imagine him and the resin stuff. He's probably like, well, we might as well just continue onwards because why would
right,
we shift? Whereas I think architects, would sort of like always reinvent the wheel. And so I think it's a little bit different, like this approach where you end up from projects to product, and then you go back to
right,
project and then product, and so that knowledge is being built onwards. Yeah.
right. Yeah, I think, yeah, I mean, I mean, that's what I experience also, that you have to take the risk, though sometimes you have to even ensure like or assure the clients that actually what you do is going to be okay, because
Yeah.
there's something, and I think that in your case it's really so much out there that there's nothing you can really reference only
Yes. Yes.
your own work. You couldn't say this is a look, there's a product that has a similarity to this, but so I can assure you it's going to work, but there's nothing like that. So
That's a good thing because then there's nothing where they can say. On the contrary, we can say actually go and see Apple. It's still up and it's still fine,
Hmm.
you know. And I think that's like you say, that's the best way to prove it.
So is it like you're gradually working towards being able to build a building, a skyscraper? Like is this the path you're following?
Our next step is facades. Like our next step is to actually use some of those on actual facades, like whether we use clay or PLA or
Right.
those wooden waves, like to actually have external semi-permanent versions of that as sunshades or stuff like that. And that's the sort of actually next step, as in the project we have now. It's like
Right.
facades. Like after that, the facade will probably become a little bit more integrated with, say, the staircase and so on. I mean, for us, it's like just saying facade is already a challenge because we need to
Of
add
course.
UV stabilizer to the material,
Right.
uh, antioxidants, stuff like that, where or fire rating. The fire rating. It sounds
Right.
boring, but all this is a really exciting experiment because how much of that then makes the material non-environmental anymore? Like how much fire, like
Yeah. Fire rating is always the
That's the
it's
killer.
huge for a
yeah.
facade.
It's
Yeah,
always the one driving force that makes the environmental issue really difficult. But it's
very exactly.
but but still, I mean, I'm really looking forward to that. I'm sure you're going to make some super interesting facade. Maybe Arthur, you want to continue with your
Yeah,
talk
with pleasure.
and
With pleasure. It's good. We got the geeky ones out, as in the project, and now it's a little bit
okay.
more fun. Uh, so it's
Okay.
kind of on purpose. So like when I get your fresh brain, I get and now I can take you to a place a little bit crazy. So obviously, I was going to talk about this because that's where I ended up in. I say that because I'm not at all a festival goer. Like I used to wear a suit all the time, and I got a little bit sort of brought into that world where I ended up in leggings and so on. You'll see, but the general idea, but it wasn't my. I just ended up there because basically I was going to teach at University of Westminster, and we needed a topic to teach, and my friend went there, or his girlfriend went there, and came back and said, actually, it's very deep. There's a lot in there that is way beyond just the parties. And then we looked at this, which is the 10 principles of Burning Man. And it's true, when you look at it, it's got leaving no trace, it's got self-reliance, things like gifting, which is related to the what I was talking about, grasshopper and so on, inclusion, which is a massive topic now, communal effort, collaboration, and so on. And so we're just really interested in teaching the students those values through the making of projects. And because it's a city that happens in the desert and then unbuilds itself, leaves no trace, and then builds again, every iteration of that city is different and has innovation to it. And so this is really fantastic to find a city where you're in charge of your own sewage, of your own, I don't know, energy and so on. Like, how can you be more aware of self-sufficiency than a city where you have to be in charge of everything? And so the other thing that I thought was fascinating is there's no spectator per se. There's no like DJ that comes and play, and it's like everyone is the artist. Everyone has to come and be the maker of their own like city, and so that becomes really, really like really holistic, complete. And I'm sure you're aware of Buckminster Fuller. We talk about Freoto. This is another hero who wrote the book Operating Manual for Spaceship Earth, and is a real advocate of the holistic approach in design, to be aware of all the systems that are there. So not just obviously the structural system, but also the environmental systems and I don't want to bore you with MEP and ducts and stuff, but all the way to the sewage and everything that we eat and everything that we produce, an awareness of where it comes from and where it goes. And so our students were studying Buckminster Fuller, studying Burning Man, and they're obviously very broke as students. And then so they ended up developing really interesting systems where we were saying, well, what if you took a sheet of plywood, like the usual 1220 by 2440, then you cut it in half, and then you end up using symmetries, and then you end up doing reciprocal structures from them, and so on and so forth. So every project had to come with like a material intelligence in terms of the shelf stuff. Like this is a hexayurt. It's a really, really like insulated place where you take a sheet of foam, you cut it in half, and then you get this sort of ecosystem of yurts where you can live in there. And so our camp where we lived was made of those. And this is an open source system that we can participate in. So not only did we have to design and build and fundraise, but we had to also live in the desert for about a month for some of those projects together with the students. So it doesn't go more like holistic than that. And it's obviously a very personal journey. But I wanted to show you these two projects before moving on to the temple, because on the left we had this crazy parametric reatomic complex numbers based like reciprocal structure, and on the right we had this simple 2x4 offsetted a little bit with a screw. And I was like, this is going to be too simple. We need to work on this. It's so cool, and so on. And I think my parametric ego got a good lesson there. So this was the structure on the left. So this was everything was custom, no symmetry. We received these from the laser cutting company with no names. So giant puzzle that we had to reassemble and realize which was what. And the other
Yeah.
piece was just cut to size, off the shelf timber, 2x4, 4x4 inches, really, really well, like tidy on the truck. And then this guy, like, we just bunched there, like, and so obviously then you realize that why the truck has a say in the design. And I think for me that was a massive lesson. Like, is the truck the designer? Like, like how to transport things, how to assemble things, is that part of design? And very much so. Like, we didn't finish that project. It looked like weird, like then it's Burning Man, so you cannot finish a project and it's fine. But these guys just finished on time and they were enjoying themselves on this really beautiful thing. And we were just like, oh, that hurts. And then you can't even climb it and so on. So those two projects had a baby before Galaxia, which was Tangential Dreams. And this was just a circular saw and a matrix of measurements, that we extracted from the graph mapper to create these tangents where people could write their dreams on. And this was really like good. We finished on time. We managed to illuminate it with these really nice LEDs that would catch the tangents would catch the light, and people would write all their dreams on that. So there was a real interaction with the community. And so I think it sort of resonated with the other piece at Burning Man that they build every year called the temple. And the temple is a space where it's actually quite deep. People put like really personal messages. And this is what I saw the first year I went to Burning Man. This is like a CNC built, no screws, no fasteners, amazing pyramid by an architect called Craig Fleischman. And he built this like huge, huge thing out of a CNC. And remember when I said like we weren't taught how to use CNC for building or how to use laser cutting. And I saw this, I'm like, okay, like it is possible, right? And who would have thought out of all places in the desert I would find that? Um, this was 2013, and I'm like, okay, I want to build something at Burning Man at the scale of a temple, at the scale of that, not just because it's really, really deep and meaningful. It has content that people relate to, but it's also a sort of really nice way to prove that actually we can be the makers of our own project, just like they were at the age of the cathedrals. The master builders were designers, makers. That was the best example, the cathedral age. And then I was like, okay, so the dome is obviously something that all temples were having as a sort of way to own the celestial field around us. But the inverted dome relates to what we understand of the galaxy, the black holes, and the fact that black holes, they warp space and time, and so we have a much better understanding of our universe now. And so the temples really can relate to our understanding of that. And I say this because we have Stonehenge here in the UK. You have you have many places of spirituality that relate to the environment somehow, of our understanding of nature. And now that we have a better understanding of that, I thought it would be interesting to make a temple that reflect our understanding. And obviously, it's an ambitious thing, but what I thought was really interesting here is that the project was started as relatively orthogonal as a portal, and then was sort of sucked into that black hole, which acted like, I don't know if you know, but if you're close to a black hole, you get spaghettified because the the difference of gravity from your head to your feet is so huge that you turn into a spaghetti. And so that's what happens to these modules. They start orthogonal and then get spaghettified as they go up. Gets relatively hard to build, but they get smaller at the top. So this shows a lot of what Burning Man is. You see those those hearts that are stamped by the community. That's just a guy with a stamp, giant stamp that goes around. And everyone has their activities and interact with this. You can see here, for example, the Bjarkingles group, they came as a team to build this giant dome for some reason, which was really fun. And then you have the entire city at the back that where it's everyone building their own camps, and then you have art everywhere and people cycling to all that art. And so we did these benches on which people could kind of put their bicycle and then like rest a bit before they enter into that space. And I say this because when you enter into that space, it's quite heavy. You see like people writing about like deceased relative and so on. So it's quite a and it's quite a serious space to some extent, and people cry, and you hear people cry. I say this because people might imagine it's parties everywhere, but it actually has a function as a temple. And obviously for us to build this was a mega challenge. I mean, you can imagine this is 6 months to from the moment they announced that it's us to the moment we build it. 6 months to fundraise about $500,000. 6 months to build a team of 140 people. 6 months to prefabricate something that we're going to build in 18 days in the desert. So obviously very, very, very complex. So the simpler we can do the construction, the better. So obviously it's rotationally symmetrical, which means that as we have one module, you multiply it by 20 so that you learn from it. You learn as you're building. So that was really important, the idea of making something easy for others to learn. Something that's adjustable on site because nothing fitted, obviously. And so we had this bike wheel in the center that we could adjust like a bike. So we would like unscrew it, move these, and then screw it again. And so we didn't have foundations. Everything was in tension. Really important. And then off the shelf stuff, things you can adjust on site, screws, 4x4 timber, 2x4, half a 4x4, nothing crazily digitally fabricated. And then also assemblable by a lot of people because everyone wanted to participate on that project. We received about 600 requests to come to be part of the team. And so we didn't have a shortage of people, but we definitely needed to find ways to have all these people involved somehow. Involvement was key. And so here you have like, I don't know, I mean, it would never happen like this on a building site, but we built these bricks that could be folded as origamis. You had like Simpson plates on here. And then people would like, it was almost a celebration to close these off. And then the crane would come and pick them up and place them together. So we had this like matrix of unfolded modules that were placed together to form the petals. The petals would then like kind of sub-built into these, we call them bananas, So it started from the 2x4 that we cut in Reno beforehand in San Francisco and Reno, assembled into triangles, then placed into a unfolded brick that we then assembled together and put into these bananas, and then put the bananas together. So we gave this IKEA like manual to all the builders, which were just kind of non-architect, non-builders. They were just people from all walks of life. And we used as much of the shelf stuff like Simpson plates, Simpson screws. The only digitally fabricated stuff was these corner pieces to reinforce the corners. And these were laser cut based on the forces going through the project. So we were told by Format, our engineers, like, that's the kilonewtons. That's what a screw can take. Deal with it. So pretty much. That's what happens when everyone is a volunteer. And so we put this in Grasshopper. Obviously the number of screws depend on the number of kilonewtons. I mean, you see the risk we took, right? And put that formula, and then the software, let's say, will just output the plates. And then it would tell us where we could use 2x4 inches timber and where we use 4x4. And you had this really smooth transition between the pieces, which was really nice because all the pieces worked. There wasn't like a hierarchy of piece. Like they would all work together, which is a great like metaphor of our team to some extent. And so there was this real sense that every piece mattered. And that was a real beautiful way to involve everyone and let them know that, because really it was really, really hard. I got married in there because I knew that otherwise I wouldn't have a girlfriend by the end of that. So you see, taking risks, but eventually like involving the people around you. So even my parents came by and my best friends and so on. And so we got married because the symbol of that piece as a temple was really, I mean, it would have been sad not to actually like celebrate something spiritual in that place without, And then we burnt it. This is a big ritual, and everyone is like, you're crazy. Like, why would you burn this? And obviously, I didn't want to burn it. Like, I believe, the Eiffel Tower is behind me. I'm from
Yeah, we
Paris.
saw it. Yeah.
I had a secret, like, wish that someone would say, yeah, it'll stay. But obviously, people put very, very personal thing in there, and to be honest, it was meant to burn because this is part of the silent ritual, and we didn't use that much timber. At the end of the day, we used as little timber as the same density, structural density of that project was the same as foam. We talked to our engineers about that, and so it was a very light material. Obviously, we don't want to burn it, and our next project you'll see what is not something we are going to burn. We're going to disassemble, but then we have to reinvent the ritual that goes with it. So here
Mm,
we
mm,
recycled all the steel. We had these crazy like magnets, rakes, and everything was recycled and so on. We decided to go back and reinvent that ritual of burning by disassembling it. And so, but then how do you create a disassembly that's as beautiful as a fire? And so that was our next challenge before COVID happened. Ended up drawing something that looks like a COVID virus for some reason. Maybe it was a,
mm.
a sign. And so this is a Poincaré disc. It's a four-dimensional field of circles that goes thinner and thinner. And we thought it was a beautiful metaphor because we were asked to design an amphitheater to create an amphitheater made of amphitheaters where no one was the spectators. You couldn't just have one show; you'd have many shows. And so we were going to disassemble this and bring it back to London in the Somerset House. We had everything sorted. We are going to build it, and then COVID struck. And it's interesting because I mean you'll see where this ended up, a very very unlikely location, but we ended up like really really learning from that process of using the local materials. And those are two projects that we're building, one in Mexico, one in Bali. And you see that every time it starts from this dude like showing us how much his material can bend. And so instead of doing the usual grid shell, we bend the material and try and keep the material straight. And so we unfold the material and like bend it back into not cutting anything. But how do you achieve curvature from that? And then also we use reclaimed things. So this is an entire bridge in Borneo. So instead of cutting the trees where the orangutan live and stuff like that, we try and use reuse any materials that we can find. So we ended up in this case like buying a whole bridge that wasn't used and then disassembling it. And we were hoping to build this. It's a slide. I can't show it. It's a slide variation of this. This was in San Francisco, but we're really excited to continue that journey on much larger project, obviously. But that's only because we could take it one step at a time.
Mm. So it's a lot of trial and error. Like you basically step forward and then you just check if it's possible. Like I think that's
Exactly.
really fascinating. I mean, I mean, now I realize like this is part of prototyping but it's also very like analog as well. Like, it's a digital fabricated, but it's also the human being is a big part of this production. And so I think it shows that, I mean, that, like the scare that robots will take over and there won't be anybody building anything anymore. I think that's proves that this is not going to be like that. But
Yeah.
yeah, I think it's super fascinating to see. Did you actually make the Burning Man Galaxia? Uh, did you calculate how much it would burn? Because it's actually very thin. So, I mean, did you have to put more things in to make it burn?
It burned so quick. Like it was
Oh,
actually relatively scary because as we were obviously like we held a torch with my wife and we put it down and then literally we had not even like a couple minutes to go back before it was the image that I showed you.
hmm,
It's
okay.
absolutely crazy how much like the oxygen, I guess, was just like there was so much of it. So yes, we added more wood in the center because we were worried that the outside would burn before the center, and
Oh, yeah.
therefore you would have like a collapse before the whole thing burns. And so
Ah,
we added
okay.
we had material. The whole project was meant to have a facade, and we didn't use the facade because the bones were so beautiful
Hmm,
that we
hmm.
thought it would be a shame to think this needs a facade because it's a building. And so we used that facade as firewood at the
Ah,
end. I
okay.
feel bad to say that, but we also ran out of time, so that's also why we didn't put a facade.
But it does look amazing. I
Yeah,
can fully understand. It's always the question like how much do you continue, like how far do you take it? But if you put it in the facade, probably would have looked very different. And I think it's beautiful that you decide not to.
Yeah, it's
Yeah.
you know it's quite natural. Like in a way, it's a funny thing, but when you work with people and you work on things where people can see or be involved, it's sort of a consensus what's better. It's not even like, and I say this not in a politically correct way, like when you see something more beautiful than something else, and if you listen well, often it's pretty obvious what's better.
Yeah.
And I
Yeah.
notice this all the time.
Mm.
That's why I'm not so worried about asking or letting others take, like decisions that might scare a designer in a way, because you want to be
Mm.
like the designer, I guess. But when you start placing things in front of you, it's very, and I don't think I've ever come across a situation where I disagreed with the majority. And so it's really interesting process. Like we have this thing in the office, we have Slack. It's like a way for everyone to be on the
Mm.
platform. We had this for Galaxia. And when we had to take decisions, obviously, yeah, I don't always consult all the time, but when I did, everyone agreed on the right solution. And the facade was the same thing. We just said to everyone, like, do you like it like this? And the answer was overwhelmingly yes. And I
Mm.
think because we took that decision together, it's okay. Like everyone sort of agrees, and I see this a lot in our work, and that collaborative approach that you mentioned is a lot about that.
Mm. So also decision making,
Yeah.
like, mm. Yeah. So I like to also ask the audience now to make sure that we ask early enough. What we always do, Arthur, is we always say that whoever asks a question will get a free beer. So
I like it.
this, so we're not sure yet whether somebody, but I'm sure there are many questions on your work. So would like to ask the audience to participate and to see if somebody wants to ask a question. Just please go for it.
Do
Is
you
there anybody?
do you have a spreadsheet of the beer, like the names, the email?
Well, I mean, it's amazing how we can still pay for it. It's such a limited amount.
What's
Good,
the
That
good.
idea
we
with
are
the
doing
beer?
it. So,
I asked the
yeah,
student not to
yeah.
flash mob me.
Simon was the driver in this.
Oh, good. So you have a lot of beers in your beer credit. Your beer credit. I like it. It's the German currency beer. Beer coin.
Anybody wants to raise a question? Like, is there anybody who would like to ask how to make this possible? Because I think this is shows to me, and like especially for like when talking to the students, this is how you could set up your office. You can actually go there and make things. And that's what is so beautiful to see, and also to see how it slowly develops into bigger things that
Yeah.
you become more confident and you become more
Mm.
reliable on your own skills. So you can actually develop it, and it shows that gradually over time. I can imagine that this will pan out into a whole different scale. So I think this is a great example of also because most students, of course, are asking me, what do I do afterwards? How do I, how do a lot of people want to be, making themselves.
Yeah.
This shows clearly how you can.
But
But
also,
also, what I think what's really important is the collaborative. Sorry, I just want to add the partnership that you made with so many
Yeah.
people. I think that's
Yeah.
another key takeaway, I think, from your lecture. It's so important to drive this, I guess. Anybody wants to ask a question?
have you had the situation that you were asking a contractor to build something for you and then decided, let's do it ourselves? Because I think I have the theory that if you do it yourself, you collect I'd call it the angst prize, because I have done some parametric facades, and we got ridiculous offers because the companies just didn't know how to do it, and so they said, okay, we add to our regular fee the triple because we just don't know how to do it. Yeah, because they,
And first of all, Simon, you're getting the first beer, by the way.
True.
From yourself. Already start drinking.
No, yeah, I mean, it's very true. Not only do you get the angst price, but you also are such in control of your costs because here you go, perfect. Yeah.
thank you.
Yes, amazing. So when you're the contractor, I mean, it's like it's quite crazy how much you realize the real prices of things because when you buy a product you're obviously buying like years of research and you're buying like the labor going through it, the marketing stuff and all these budgets that accumulate. And then when someone is like, well, can you do I don't know, can you do that special project for us, and what's your budget? And then you're like, well, you realize that the design fees, the architect's fees are nothing compared to the budget of the project. And I mean, I'm sure you're all aware, like, we might make 10%, like maybe 15, maybe 20 if we're lucky. But the budget is the thing.
Yeah.
And yet we are only the designers of the things, but we're not involved in the pricing of the thing. And so we're separate from the thing, although we are the author of that thing. It's so weird. It's like if I don't know, you do the pregnancy, but you don't get to, have the baby. Like, sorry, I say this because my wife is pregnant now, but that's the only metaphor I could think of. But it's a little bit like this. You're involved with the conceptualizing of something, but you're not involved with the actual like realization of the thing. And I always thought that was a bit strange. And I think it happened because of risk and de-risking and the fact that we just ended up wanting the credits of the authorship and stuff, but not get like you say, the stress of the actual thing itself and how it's going to collapse and who's responsible for that, but that separation ended up making us more into artists or maybe into like conceptualizers, and then we ended up getting quite disconnected from the general public and from what it is that we actually do as architects. And now we just focus on fees of design fees. Therefore, we end up working with rich clients because those are the only houses that are expensive enough for our 10% to mean anything. And so we ended up just looking after rich client, and then it became like completely not democratic. And so we and the architects only do like 1% of all the construction in the world or something. And so I mean, I don't know if it's the same in Germany, but that's sort of something I've noticed here, and it's sad. Like, why are we not doing like homes for people? Why are we not why are we not hired to do like projects that are for people that can actually afford us, like they could afford a doctor or, we became disconnected. And I think it's partially due to that separation between design and making. And so I'm doing my home now, and we're building our home, and we're, you can see on Instagram, like I'm talking about boring things like ducts. But it's so interesting when you are actually involved in the making of a home, because you realize how much the intelligence of digital fabrication can take over some of these aspects that we thought were just away from us.
You're building a facade too?
Yeah, well, everything in our home really, but
Great.
in the case of, like lately we've been involved in things like, spaces like, we're building partitions, we're building like the wiring system for a sort of giant interactive, like 150 meters long, not for my home, but in Paris, for example, we're doing that gigantic illuminated wall. And so we end up like asking about things like, I don't know, the current, like the electrical currents and who's doing what and who's responsible for the high current and the low current. And I'm just like it's crazy when you start making and be the contractors, the type of things you have to learn, and you're so responsible. You're responsible for so much that if you're not in a collaborative spirit, or in a spirit of opening up and understanding from different trade, you're just like, I can see why designers were disconnected and ended up being conceptualizers, because what I'm learning as a contractor, I'm just like, oh my goodness, like amazing to learn about things like that.
Arthur, we have also, I see Jim.
Hello, Jim.
Jim Mendenhall, who's here yesterday. He's from Zena. Sorry, I hope it's okay, Jim, to mention that you're there. And he's also he's basically from Zena, where they produce these. He showed like these massive,
Amazing.
huge stadium, which was with all these 37,000 panels and all are
Amazing.
different. And yeah, so I'm just interested. Jim, did you see some of the lecture?
Yes, yes, yeah, it was very intriguing stuff. And I actually did have a question too
Yes.
for
Great.
Arthur. So you mentioned PLA, I think,
Yeah.
some timber, the sand, the local sand
Yeah.
material in Saudi Arabia. Are there any other materials that you see as like that's the one new thing you see upcoming that really intrigues you?
Earth, clay. Like to me, that's the holy grail. Like we
Yeah.
just got a clay printer now, like terracotta. Well, simply because it doesn't get more environmental than that. You literally don't have to like cut a tree or like it's everywhere. It's renewable. You can compost things back to earth. Like so the cycle is cycled. Like you don't even need to grow a tree in that earth. You just use the earth, and then it goes back to earth. I think this is like fantastic what's going on, like the I know, for example, WASP is doing like these earth project that they 3D printing, and they're I mean, I know because I talked to them quite a bit, and it is a struggle because earth is obviously not very good in tension as well, like the sand I was mentioning. So what do you use as the added thing, like timber? Or obviously you're tempted to use steel, but then steel is not very environmental. So like yeah, but maybe PLA and maybe a mixture between the PLA and the earth. Like it's so exciting to kind of start thinking in terms of environmental cost, not just cost. Like what is the environmental cost of steel, of concrete, of wood, of earth, of glass? Like should we use PLA instead of glass? Like glass is not a renewable. So how do you make materials from renewable? Like you talk about mycelium. That's an amazing insulation material. You put like, could we think of I don't know, like earth, mycelium, earth, and then like it turns into PLA for windows? Like, could we think of systems that are only using renewables? Like it's. I mean, you guys are Zainer, like you are the example of the designer makers. Like it's. I feel pretty humble to have a question from you, but it's quite nice if you guys are exploring like the environmental cost, not just because I noticed that people just revert back to plastics and epoxies and resins and because it's just certified and we have years of certification of plastics and like the other day for my house I was exploring for bamboo flooring, and then I dig into it and it's like bound by epoxy.
Yeah.
I'm like, oh, and they sell it as an eco product. I'm like, oh,
Yeah, but most of the timber is full of
yeah,
epoxy, full of polyurethane or whatever. Like that's of course a problem because we think it is environmental friendly, but it's the truth
exactly.
is all the CLTs that we're working with,
Yeah,
like in housing now, it's not just timber. There's a huge amount. It's just a different material that is not environmental friendly. Or
yeah, yeah,
let's say you can't rebuild it because, and I think that's of course part of this digital fabrication that you can actually rebuild things. You can undo things, which I find is so spectacular. You can just take it apart, use it as parts that can be used elsewhere if you know
yeah.
exactly. I mean, Jim had yesterday this drawing showing like every single piece, and you could imagine that in the future, if let's say this building needs to go away, you could disassemble it and use it for many other houses, or you could repurpose it
Amazing.
if you
Yeah,
know exactly what it looks like, and like urban mining, this kind of this notion that we reuse stuff. So and then of course the idea what you said is to degrade everything, kind of get it back into this kind of biological cycle, to make it as a kind of what do you call it, Nährboden, like it's a nutrition for the new things to grow out of it. But
yeah,
no,
you're right.
it's really fantastic. You're right. There's such a huge opportunity at the moment. I think there's this huge new wave of materials. I think, and because I think that we're in a material crisis. We can't use the materials we work with in a couple of years because most of them don't have they produce too much CO2. at the moment. And so Germany, for example, like Europe, they want to be environmental, carbon neutral in 2050. How do you do that? You have to, basically take out all the materials that we use at the moment for construction. So it's quite a big issue. But I want to
plus keep an eye on and not producing monocultures when we grow bamboo or trees, because that's a great other issue that we step into. If you say okay, let's not use concrete anymore, but use timber. Where does the timber come from?
Yeah. Yes.
So
yes, exactly.
The clue is not building so much and reusing old buildings.
Sure.
But that's not what
it's tough as architect, isn't it? No, you're right. Sorry,
Jim. You get the second beer. And by the way, we're not just offering beer. So if somebody just wants to drink orange juice, we can do that as well. I know there's somebody in the chat. Okay, good. I knew it. And we're in the chat line. There's or I don't know who to ask first, but because Mr. Künzer, I see your picture. Do you want to ask a question?
Yeah, I'd like to ask a question. My question is, did you ever make something like a positive mistake in programming? So you connected some nodes in the wrong way and ended up with something more interesting that you actually had in mind?
Yeah, all the time, every day, like literally even yesterday. And that's why I teach also, because I teach Grasshopper. I do the evening classes on Wednesday night, if you want to join, by the way. And honestly, sometimes I start teaching something, I have no idea where it's gonna get us, but I just know roughly how to do it. I don't know exactly how to do it, and I just go for it. And then I just realize things midway, and I'm like, oh my God. And so I start taking notes of things that I'm showing, and it's sort of a jamming session, I guess. Like in jazz, you start an improvisation and then you realize that, oh, I didn't know that note was possible, right? And that sort of open-mindedness, open-ended grasshoppering, I guess, is very similar to that jazz, impro, because you're just kind of, you have a bunch of people next to you, and whether it's students or teammates, colleagues, we do this all the time. Today we sat down to do some facade, and we start things, and then the software is almost part of that jamming, as much as the saxophone, I guess, is part of the jamming of a jazz player. It does things. We were playing with control points, and then suddenly realize, I don't know, that you can compress things, and you can use a certain tool that we didn't know about. Today we discovered about the tangent Bezier curve, and then we sort of do it recursively and start varying it, and it all the time, whether it's something you want to do and you plug the wrong thing, or it's just a new tool that shows up and you're like, oh my God, I didn't know I could use that. And so all our projects, and then it feeds all the projects. We discovered that Bezier thing, and then we share our discovering, and then all the project starts using it. And and so that's how we go from, say, the wooden wave to suddenly a project that looks like the wooden wave, but then is emerging into something new. All the projects are technique based. Even those waves were based on just having we couldn't print a double curvature, so we ended up doing this this line that compresses the space, right? And then that line is tangent to the to this border, and therefore the next one feels like a continuous piece, right? And so that curve is a sort of exercise in tangency, and so then it just ended up in that tower that you saw, the towers that that are also, I don't know, everything sort of feeds each other at the end. So it becomes an ecosystem of projects that interrelate in their technique, but always gets a life of their own somehow.
Where you said you're making classes, those are public.
Yeah.
Are you uploading them on YouTube or?
I don't think they are.
Basically, where could I find them?
Well, so my Grasshopper classes are, I do the level 2. There's level 1, level 2, and you can find them on simplyrhino.co.uk. Yes, it's true. No one really knows about it. I guess we could advertise them a bit more, but it's always small committee of people for 7 weeks, and then we go very deep into Grasshopper stuff. Sorry, I didn't mean to sell my classes, but yeah, simply Rhino.
Yeah,
No, there are a lot of
we can
fans in the
probably
audience.
we can put it in the chat line. I mean,
Nice.
there's also a question, I mean, from Sharon Slimani
Uh-huh.
on the chat, and I unfortunately don't know she or he. Sorry. Thank you so much for this interesting lecture and sharing your projects. I have a probably really open question. I would like to do a research on parametric architecture and digital fabrication. I'm kind of lost on where to start. Can you suggest what to focus on and what are the points to keep in mind?
Yeah, I mean, it's the kind of stuff where you have to practice to research. It's very hard to open a book and learn about parametric design. It's funny, obviously there are theorizers of the field, but I find that our research came from the practice. It wasn't at all like I sat down and I was like, I want to do a temple, or I want to do like a kind of research on folding. It was more like, need to fold that thing because the client wants origamis. So how do you fold stuff? And then you start doing it, and like Emil was just saying, like suddenly the folding becomes crazy in the computer, and you're like, that's cool. And then you keep a print screen of that, and then you start doing iteration of those sort of discoveries, and then you realize that parametric design is about the tweaking of little parameters to let a sort of ecosystem of geometries emerge from a set of parameters. And then once you kind of know that, you start documenting all these things that are happening in the computer with slight variations, and you create these matrices like I was showing, and then you become passionate about the tiniest variations that you find. And then let me grab something. Like this thing I found in the sea, like I don't know if you can see it, it's a dried coral that and you're like, wow, as nature does the same thing. Like that thing gets thicker because it needs to be thicker. And then you start looking at nature and the things around you, and you're like, well, it's actually something that nature does. And that's a big surprise, is the more computer-based design is, the more natural it become. I find this a real paradox. but it's I think, yeah, I don't even know. It's an open answer to an open question.
Yeah, I think for me the question is also like basically how to solve all these problems we're going to have in the future. So I think some of it will come back from nature. I think we need to introduce nature more into our design process to be able to go back to nature in a way. So I think it's like I agree. It's basically something that the more we do it, the more we become more natural designers or naturalistic designers in a way. Are there more questions? If you have questions, it's like standing up in the audience. You can just turn on your video and just ask questions. So we only have sold so far like 3 beers. So
Do you have a second question?
Great, 2 beers.
Emil,
Yeah.
I'll get the beer deckel. What is it called in English?
But it's a fairly simple question. Do you think that 3D printing will be a bigger part in the building business in general in the future, or do you think it will more or less stay in this niche that it is right now?
No, I think it's got a huge role in the future, especially when it comes to local fabrication and like sending files to like each other as networks of spaces where you can fabricate. I feel like every designer will have access to a maker space of the scale of a, fabrication kind of space for large scale stuff. Like there's going to be rooms with giant printers that all architects can access, and then they will send, no matter where you are on the earth, you can send your codes and they will be locally printed. And I don't know if on-site printing will become something. It might be that those spaces prefabricate components, and you have other kinds of robots that assemble them. Maybe, that's why I was showing the spider crane thing. Because I feel like 3D printing is of course the extrusion of material, but it's also the technology to move things in space and place things. And so pick and placing, robotic cutting, or all this I see as the revolution of digital fabrication, not necessarily just the 3D printing bit, which is one aspect of it to some extent. But digital fabrication has a huge role to play, not just in the architectural world, but in the sort of decentralization of making and the owning of the means of production. I don't want to get political, but Karl Marx was saying that the power is in the who owns the means of production, right? That was the basis of communism. But it's true in the sense that if you have the means of production to make your things, then you have the power, because that means you can be part of what it is that you make, and you're not reliant on third parties or suppliers. And I think there'll be, just like there is Facebook now, there will be Facebook of making, and there will be places where we exchange our digital files and our making, even to the extent of our food. I think we'll be sharing, we'll have, those chefs sharing like G-code to print the foods that you'll have in your kitchen, or the clothes that the next Iris van Arpen, you'll have a printer in your cupboard where they'll print your next clothes, and then you'll put it in the recycler, and then you'll print another piece of clothes. It wouldn't mean that you cannot have diversity in the things that you have. It's just that you'll control that loop. You'll probably grow your food as well, and grow your materials and your plastics and your and then you'll put it back into the system, and then we'll just have these closed loop spaceships in which we live. I'm sorry, I went really far in the future, maybe, but that would be exciting.
There's one more last question, I would say, by Jonas Gorgas, I think.
Yes. When you do the workflow with parametric design, in what direction do you work? Do you work from, okay, we have this shape we want to create, what material can we use? Or do you work with okay, we want to build a pavilion with wood? What shapes are possible to build, and with what parametric design is it possible to shape wood in this way?
It's a hard one to answer to, and it's a good question because there's so many different starting points. Whether it's a client that says, I like Galaxia, I want that, but I want it in bamboo, and I want it in that site that cannot fit that, and therefore we start adapting it until it just becomes something completely different. Because often when we are approached, people have seen the work and they want something like something. It's very rare that they come and say, I want something completely new. You have carte blanche. Yeah. It is very rare. I don't think it ever happened. I mean, maybe it will happen in the future more, but they'll come and say, I saw this on your website. I have a space like this. Maybe we could have it. And then so that's where we usually start, is from something we actually have already done. And it looks new because you cannot just copy paste something. There is a different ceiling, or there's a different space, a different site, a different material locally available. And so we use the algorithm to start with, but then it sort of is informed by parameters of site, parameters of materials, and so on and so forth. So it's usually like this that it starts. Someone says, I want catharsis, but that project I showed you, but I want it made of earth. Or you remember I showed Burapple. They say, I want Karen Millen, but made of wood. And so it became something else, but it started from that algorithm,
But it's interesting, you can change from one material to the other but having a similar design approach, let's say. It's
because it's mathematics, right? It's like it's curves, it's Bezier line, it's when we teach Grasshopper, we teach like the parameter of a curve, the one-dimensional point, the two-dimensional points, et cetera, et cetera. Like, so all this eventually comes down to mathematics, and math is so abstract that then when you start taking a math equation and then we add materials to it, we add physics, we add a site, we add all this, the math becomes an object and a real thing in real life. But you could eventually abstract it to mathematics. And I mean, maybe the starting point would be to study some equations. That's how I started. I had this teacher, George Lejeune, who took mathematics and then did buildings out of it. But it was maybe a tiny too purist, maybe. You know, but that abstraction, that level of abstraction, is quite good to know, because then that's also a way to gain control and power over what it is that you're doing. You're not dependent on your software, which could be a bad thing about parametric design, is you don't fully understand what's going on, and therefore you're a bit of a victim of the software, you know.
Yeah.
So don't be a victim of the software. That's a good ending. And yeah, so Arthur, I think I would like to close this digital maker series, and I think it's been amazing to have you here. I think it's fantastic to see your work, and you know, to hear so much about it. I mean, obviously you also, you know, show a lot of enthusiasm, which really comes across, and it's fantastic to see, you know, and to see also, I mean, I think we learned a lot about this whole digital fabrication, what it does, I mean, how it actually works in process, and how it kind of dilutes the kind of systems that we have so far, you know, and I think it's, you know, really exciting to see how, you know, the collaborative is really important, you know. There's so many aspects, and well, I think it's been an amazing ride the last 3 days, and it's been amazing to see your work as a kind of, you know, highlighting many of these issues, and I think it's fantastic. I'm really curious now, and I don't want to stop. You know, I'm excited to see now the next thing. I want to see what's Frankfurt, and you know,
It's happening soon.
You say we can imagine it, but I don't think we can. So, you know,
Oh yes,
and
maybe.
in the end, it's going to be amazing. So, you know, obviously we're looking forward to it, and hopefully we can invite you and Jim and everyone again.
That would be great. Yeah.
And then we redo the whole session and check out how it all kind of evolved. But thank you very much for coming.
Thank you so much. Thank you.
Fantastic.
You for staying till the end.
Fantastic. That was great. It was really great. So thanks.
Cool.
Thank you. And yeah, thank everyone who joined. And we have recorded this, and we'd like to, you know, save it somewhere where people can watch it or show it to friends, promote all the work, and yeah, and get it out there. So thank you very much.
Amazing. Thank you, everyone.
Thank
And
you.
see you soon, I hope.
Super.
Yes, we'll see you again. Okay.
Bye-bye.
Thank you.
Bye-bye.
Bye-bye.
Bye.
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 Thank you.